Looking at section 4.1, example 1. So hopefully you've read about the constant multiple rule and the product rule for taking derivatives. So let's do these examples. So we got to find the derivative of the following functions. The first one is f of x is equal to simply pi squared. So this is maybe a little bit of a trick question. When you see that squared, you might think that, oh, well, we have to use the power rule here. But remember that pi is a constant. And so it's the derivative of any constant is just 0. So for this one, it doesn't matter what the constant is. The derivative is 0. OK, for the second one, we've got a function g of x is equal to the square root of x. And whenever you've got a root function like this, remember that you can use the power rule on it. But before you do, you have to write it as a power function. So in this case, when you have a square root, that's a 1/2 power. So the derivative, just use the power rule. Take the 1/2, put it in front. So we get 1/2 x. Then lower the power by 1. That gives us negative 1/2. And then if you want to, you can rewrite this back in its root form. So the negative power means that it's going to move to the denominator. The 1/2 means that it's a square root. So we get 1 over 2 square root x for the derivative of that one. And then part C, similar again, just realize that when you have the variable, the x value in the denominator, you can write this also as a power function. So that's the first thing you'll want to do. Write this as a power function, so x to the negative 4 power. And then we can take the derivative of that using the power rule again. In this case, we're going to use the Leibniz notation for a derivative. dy dx, that's the derivative of y with respect to the variable x. So power rule again here, we put the negative 4 in front, so negative 4x, and then we lower that by 1. That gives us a negative 5 power. And if you want to rewrite this with its positive exponent, you can move that 5th power to the denominator, so we get negative 4 over x to the positive 5th power. So that's the derivatives of these three functions using the power rule.